Hello, my name is Darren Fee. Thank you so much for tuning in to this channel. Today we want to see how we can integrate partial fractions involving denominator of first degree. Now this is third in our episode of partial fraction integration. If you have not watched the part 1 and part 2 that laid the foundation for this, we encourage you that the link is below this video. Kindly watch the two videos, but if you already have the foundation, then we are good to go with this one. Once again, if you have not subscribed to this channel, we urge you to subscribe, because most of the nice videos coming, once you are a subscriber, YouTube will always give you notification once we upload the video. So now how do we integrate partial fraction involving denominator of first degree? Now if you look at this question, the numerator has a third degree, meaning the exponent is 3, and then the denominator, the exponent is 1. That means it has a first degree. The second one too, the highest degree in the numerator is 3, and then the highest degree in the denominator is 1. That is why we are saying that we are integrating partial fractions involving denominator of first degree. Now let's move on and solve the question. The first question says determine the integral of x cubed minus x squared plus dx. Now if you have watched the part 1, we laid some steps, and the rules are very important. If you understand the rules, you are good to go. So now what we are going to do now is to apply the rules in the part 1 of this video. And the part 1 says that when the degree of the numerator is bigger than the degree of the denominator, then we need to divide using the long division. So that is the first rule that we must know. So if the numerator has a higher degree than the denominator, then you need to divide. Now on the left hand side, I have the long division approach, and then on the right hand side too, I have the synthetic approach. Now in examination, no one is going to ask you to use synthetic or to use long division. The most important thing is that when you divide this by this, what answer do you get? So those who have not watched my video on how to use the synthetic method, please, the link is also down. Check up, and then you know that it will be easy for you. So first, let's look at the long division method. The long division method, we are dividing the x cubed by x plus 3. So here on the left hand side, we have the x plus 3, that is the divisor, and then we are dividing x cubed. Now if you look at the question, we have x cubed, no x squared, and then no x. So what we don't have in the question, we assume that its coefficient is 0. So this x cubed is what we see here, x cubed. But because there is no x square, we bring the x square with a coefficient of 0. And then because there's also no x in the original question, we bring the x and assume that its coefficient is also 0. Then in the question, we don't have any constants. So we assume that the constant there is 0. So that is the first part. Then what you are going to do next is that you pick this x to divide the first item under the division sign. So when x divide x cubed, we are going to get x squared. So you place it up here. Then whatever you put up here will be used to multiply everything here, everything. So x squared times x will give us x cubed. And then this same x squared will be used to multiply 3. So we are getting 3x squared. So after using this to multiply this, we are now going to subtract. That's why you see subtraction sign here. Now x cubed minus x cubed is 0. So you don't see anything here because it's 0. And then 0x squared minus 3x squared. That automatically will give us minus 3x squared. So we bring it down. So that's what you see. Now after this minus 3x squared, we go back to the original question and then we look at the next item on the right hand side. So, and that one is 0x. So after the minus 3x squared, the next item in the question in our solution is the 0x. So I have plus 0x introduced here. Now once again, what you are going to do is that we are going to use this x to divide the minus 3x. So when x divide minus 3x, we are going to get minus 3x. Once again, when x divide minus 3x squared, because there's a square here, when x divide minus 3x squared, we are going to get minus 3x. Okay, so that gives us minus 3. And you see that whatever you get at the top, you use it to multiply everything here. So minus 3x times x, that will actually give us minus 3x squared. So we have it here. And then minus 3x times 3, that will give us negative 9. So we have minus 9x. So remember, minus 3x times x is minus 3x squared. Then minus 3x times 3 is giving us minus 9. Then we are going to subtract these two. That is how come we brought this subtraction sign here. Then you underline it. We know that minus 3x minus 3x. So negative will be positive. So this will be 0. So you don't see, as usual, anything written down there. So that's how come you don't see that there is any 0 here. Then we move on. 0x minus 9. Remember, negative will be positive. So this now will be positive 9. So that's why we have 9 here. And so when we subtract 0x from negative 9x, we are getting 9x. Then, as we said earlier, you move on to the next number. So the next number is 0. So you add it to it. So we have 0 here. Then once we have added the 0 to this, we now have to use the divisor to divide this. So we use this x to divide the 9x. And when x divides 9x, you will get 9. And then 9 multiplying x is going to give us 9x. Always remember that whatever you put at the top must be used to multiply the divisor. So 9 times x is giving us 9x. And then 9 times 3 is giving us 27. Now we want to subtract these two functions. So 9x minus 9x is 0. So you don't see anything here. And then 0 minus 27 will give us minus 27. So it means that when x cubed is being divided by x plus 3, the remainder is going to be minus 27. So in effect, the new function is going to be x squared minus 3x plus 9, and then minus the remainder over the divisor. And I want to use the right one to also explain, and you see that this is more easier than using the long division. And once again, if you haven't watched our video on synthetic division of polynomial, please, the link is down. So how do I get this? Now first, you get this 3 from the divisor, this one. So you equate this to 0 and you find x. So if you look at it carefully, you will see that x plus 3 is equal to 0. When I make x a subject, I'll get minus 3. So that is where this 3 is coming from. You equate this to 0 and then you find this. Then you come to the first column, the 1 0 0 0. Where are we getting this from? Now it's basically the coefficients of the items you have in the numerator, the coefficients. So here we have x cubed, but there was no x squared, no x, and then no constants. So in the case of this, here the coefficients of the x squared here is 1. So that 1 is what you see here. And then because there was no x squared, we assume that its coefficient is 0. So on this side, you see that we have 0x squared. So this 0 is the coefficient of the x squared. So that is what we have here. And then we also went on to have 0x, because given x squared, given x cubed, there should have been x squared, x, and then the x. But none of them was provided. We only have x cubed, no x squared, no x, and then no coefficients. So if the item is not there, then you assume that its coefficients is 0. But if the item is there, you place the right coefficients there. So here, because the first one, x cubed, is here, its coefficients is 1. Because there is no x squared, its coefficients is 0. Because there is no x, its coefficients is 0. We have it here. And because there is no constant at the top, its coefficients is 0. So that's how come we got the 1, 0, 0, 0. Then how do we get the remaining portion? It's quite simple. First, the very first coefficients that you had, not the one outside the blue line, the one in the blue line. So the very first number here, you send it down. So this one is what you brought here. Now any number that you have actually written down here must be used to multiply the one here. So if you use this to multiply this, then the answer will now go to the downside of the next number on the right. So for the 1, the next number on the right side of 1 is 0. So when we multiply minus 3 times 1, we are getting minus 3. So that minus 3 is what you brought here. Then whatever you write here, you now have to add the 2. So 0 plus minus 3, we are getting minus 3. And anything you write down, you must always remember to multiply that with what is here. So negative 3 times the negative 3 here will get positive 9. So that is how we have the 9 here. And then after writing this 9, we need to add these 2. So 0 plus 9 is giving us 9. And then once you have written it down, you remember to multiply the down one with the number you have written here. So minus 3 times 9 will give us minus 27. And that one goes to the top of the next number. So minus 27. And then you add the two numbers, 0 plus minus 27. That gives us minus 27. And if you have watched the video on the synthetic method, I told you that always the last answer you get is the remainder. So here it means using the synthetic approach, when we divide x cubed by x plus 3, the remainder is going to be 20 minus 27. Remember the same thing we got here when we use the long division approach. So if you feel that the long division is easier for you, you can go ahead and use it. If you also want to learn the new technique of using the synthetic method, the video is down. You can watch them and then we go. So how do we now get the answers that we had in the long division? In the synthetic method, the very first answer that you had, the degree that you are going to give it must be 1 less than the original degree in the question. Now, what is the original degree in the question? The question that we divided was x cubed. And so it means that if you are going to give this one a degree, that degree should be 1 less than this. And of course, 1 less than 3 is going to be 2. So it means we now assign x squared to this one. And when you assign x squared to 1, you are getting x squared. And then once we have x squared, the next we are going to reduce it by 1 by 1. So x squared minus, so the 2. When we reduce this by 1, we will get x. So you simply add x to the next one and we'll have minus 3x, as we see, minus 3x. Then the next one will reduce the x. And so if there is only one x and you take it out, naturally there wouldn't be any x. That is why this 9 was repeated here. And then once you are done, we now have the remainder, that is minus 27 over x plus 3. And please, if you want to make this one easy for yourself, I have videos, 2 of them. Kindly go and watch them and you see how easy it is. So now that we have been able to break down this complex function into this basic form, we are now going to integrate this answer that we have gotten. So now let's start with the integration. Okay, so now there's the integration. So of course, I told you earlier that integrating partial fraction is about breaking complex and polynomial into basic form. So when we actually decide to do the division, this is what we have, and we can easily differentiate this. So let's go ahead and do our differentiation. So you can see, for example, that the integral of x squared minus 3x plus 9 minus 27 over x plus 3 dx. Now we can break this one down by giving or assigning integral sign to this one. That is why when you come to the right, we have separated this one from what we have here. So this is what we get. Now let's do the integration. The integral of x squared is obviously 1 over 3 x cubed, and then minus the integral of 3x, that will give us 3 over 2 x squared, and then the integral of the constant 9, that will give us 9x, then minus. So this was the reason I laid the foundation for the part 1 and part 2. So if I've watched that one, then you shouldn't have a problem. So this minus is what we see here, and then the 27 must come outside so that we can get 1 here. Okay, so if you have 1 over x plus 3 and then you are integrating, it is simply the natural log x at absolute value of x plus 3, and then of course plus c, because this is indefinite integral. Please, if you have not watched the part 1 and part 2 and this one looks a bit difficult for you, kindly watch the part 1 and part 2. You see that it is very easy to solve this. So this is how easy it is to use partial fraction when you are integrating. Let's check another question. This time around, I felt that the long division method is quite complex, and once again, the examiner is not interested in how you divided it. The examiner is interested in how you actually got the factors. And so if I have to find the integral of x cubed plus x divided by x minus 1, obviously you can use your long division to divide this. But once again, remember, when the degree of the numerator is higher than the degree of the denominator, then it means that you need to divide. That's how come I decided to use the synthetic method for this. So how do I got this? Simple. First, the divisor or the denominator equate it to 0, and then you find x. So x minus 1 is equal to 0. I will get x is equal to 1. So that 1 is what I have here. So this one means when I solve this, I will get 1. X minus 1 is equal to 0. The value of x is going to give me 1. Then how do we get all these things? First, let's go to the numerator. Now the first one is x cubed. X cubed, the coefficient is 1. So we have the 1 here. Now ideally, from between x cubed to x, there should have been x squared. But because there is no x squared, we assume that its coefficient is 0. So we have that 0 written here. And then the next one, the x, its coefficient is 1. So we have that 1 here. And then from x, there should have been a constant. But because there is no constant, we assume that it is 0. Because if it is not 0, there should have been a constant. So this 0 here represents the constant. This 1 represents the coefficient of this x. And then the 0 here represents the missing x squared. That is not in the question. And then this 1 represents the coefficients of the x cubed. So now let's go ahead and do our division. Remember, in the previous example, we said always the first number inside the line, not the one outside. The first number inside, you bring it down. So this one is what I have here. Then whatever you bring down here, you must always remember to multiply it with the one outside. So 1 times 1 will give me 1. And that one is written at the next side of the right. So this 1 times 1 is 1. So that one is what I have here. Now that I have this one, I have to add these two. 0 plus 1, I am getting 1. And anytime you finish adding, whatever you get, multiply it with the 1 here. So 1 times 1, as usual, I am getting 1. So you go to the next right hand side of the next number. And the next number is 1, so it goes under it. Okay, then once I have written this one, I have to add them. 1 plus 1, I have 2. Then these two will be used to multiply the number outside. So 2 times 2, I am getting 2. And then I add these two, so 0 plus 2, I am getting 2. So once again, I said that the last answer or the number you get, it means that is the remainder. Then after we have gotten this 1, 1, 2, 2, we are now going to introduce x to all these things. But the first number, the degree must be 1 less than the degree in the original question. What is the original question? The highest degree in the original question is x cubed. And so the first one here cannot also get x cubed. The degree must be 1 less than this. So that means we have to add x squared to this. So 1 times x squared is giving us x squared. And then we are now from this, we are now reducing it by x going to the right. So x squared, if you reduce it by 1x, you will get x. So x times this one will give us this x. Now we have x, so we will reduce the x again, meaning there is no more x to be added. So the next number is 2. You write the 2 the way it is, and so that is the factor that we are getting. And because I have said that always if you are using the synthetic approach, the last answer you get is the remainder. So now we have the remainder over x minus 1. That means when x minus 1 divide x cubed plus x, the remainder is going to be 2 divided by the x minus 1. That is the divisor, number used in dividing the function. So now we have been able to break this complex function polynomial down into this easy one. So this is what we are now going to integrate instead of integrating this. So let's now move on to do the integration. So the integral of x cubed plus x divided by x minus 1 dx is the same as what we have here. And so it is quite simple. The integral of s squared is going to be 1 over 3x cubed. And then the integral of x will have 1 over 2x squared. Then the integral of the constant will give us 2x. Then if you have watched the part 1 and part 2, the foundation, you know that this place is supposed to be 1. So you bring the 2 outside. So this 2 is what we have here. And then if there is 1 here, the integration for 1 over x minus 1, it is going to be the natural log absolute value x minus 1 plus c. And that is quite simple. And so this is how easy it is when you are following instruction. And notice that it is not difficult. Thank you so much for your time and thanks for listening.